Swift in Swift are very similar to lists in Python, and that arrays and lists are the same thing in Swift. So let's say list, we use brackets, gonna declare a list of doubles with some initialization, so 1.2, 3.4, sorry, etc. This is how we define a list, and then we do just this, and our list is printed. Let me run this. Yeah, this is our result. Okay, I didn't print to the string, to the screen, sorry, but I can take snapshot of the memory. Sorry again. Yeah, 1.2, 3.4. Okay. So another way to declare a string is to use the keyword array, which is, as you noticed, all types in Swift are implemented as classes. So you use the keyword array like when you instantiate some object of some class, and here you have the option to initialize with some repeating pattern, like initializing an array of 3 doubles all with 0.0 values. So you're gonna get this result. If I happen to need to concatenate arrays or lists, we can do as we did with strings using the plus operator. So for instance, 3 doubles, which is the first array defined, plus the second one, we will get this one, which is the concatenation of the two arrays. So let's declare a constant list of strings with these values, personal pronouns, you, me, him, or yeah, exactly. So if we wanna then use some part of this array, we can use subscripts, or we can use sublists using subscripting. Subscripting is similar to what we can do in Python. So rather than putting here a single index and accessing a single element of the list, you can rather specify like a chunk of the list by using the beginning index, which is absent here, but I can do something like this. So let's say a list that starts at 1 and ends at script number 2. At script 2, which means, sorry, we need three dots. So we start at index number 1, which is here, and we end at index number 2, which is here. So you're gonna get this. So let's just try. I need to run, and then yeah, me and him, exactly. So yeah, if you don't specify the first index, the Swift will start sublisting from the beginning. So L3.2 will take this, which means from 0 to index number 2. You, me, and him, and 3 with and the subscripting, sorry, starting from 3 and until the end of the list. If you don't specify the end index, it will go till the end of the list, and you will get this result: she, they, and we. We can run it to check. Yeah, this is the result. So here we have defined a list of 6 integers, and then you just print the list. And then if you want to print the tip of the list, you use the instruction type of, and you put your list. L2.count is to count the number of elements, is empty is to check if the list is empty or not, and the capacity is the number of elements that the list can contain without allocating further memory. So let's execute and check the results here. So before running, I'm gonna remove some element from the list using remove and add to specify the index. So here what I'm doing is I'm removing the first element, and then I'm gonna print the list and the number of elements. Wow. So let's do it. Here we go. Yeah, the number of the list is here. The type is array int. Array of integers. Number of elements is 6. Is empty, is false, and la capacité totale est de 6. Now suppose, so we removed an element from the list, right? So L2 become, we remove the first element, so L2 become 2, 3 until 6, number of elements is 5, but the total capacity is still 6, which means even though we removed an element from the list, the allocated space for the list remain the same. So if we add an element here, this list won't need to allocate further memory, because as you know, lists are data structure of a variable of a dynamic size, which means that we add to the size of the list as we go on, as we insert elements. Okay, so the first element, if the first element of the list and the index is 0, or we can get it by using the list name followed by dot start index, as I'm doing here, and the last element's index can be obtained by using and index -1. So I'm checking this here, and then if you happen to subscript an array, the elements of the subarray will keep the same indexes as the mother array. So for instance here, if we run this code, the index of 4 is 5, 0, 1, 2, 3. It's gonna be 3. Let's check it. Sorry. Oh, I could get it, yeah. And this found him, she, they is 5, yeah, as I told you. Because you have 0, 1, 2, 3, 3 and 4 and 5. Then this found him, she, they, yeah. Let's check again. What is the biggest list? 0, 1, 2, 3, 4 and 5. What did I do here? No, yeah, the end index is always +1. So if you do 2, 4, you will get 5, and that's what we got. We got 5. Okay, sounds good. Let's check if you can add an element to the end. No, actually you can't, because L is immutable. It is a constant. If you do it, you will get some error. We can check it by doing this. Cannot use mutating. Can you use mutating member on an immutable value, which is okay, it's defined with the let constant. Yeah, so you need to be careful when you handle constant lists or constant elements. Let's define a mutable array of strings. Okay, mutable, which means using a variable. Okay, and unlike Brian Jack, names one count, we said that it counts the number of elements, and to iterate through the list we can use, actually there are many ways to do it, but the new way is to use an iterator, like an integer iterator, as you do with arrays. Comme on fait pour les tables. So for I in, we start from 0, and we use the same trick, or the same manner of subscripting. We start with the first index, then we put the dots. If here, if there is 3 dots, it means that we start from 0 until count, exactly until count. But since count is the number of the elements, so the last element of the array is indexed count minus 1. So we put here less, to means count isn't included, the index count isn't included in the iteration. Print person number, and then person name, using indexes of names, which is the list, and e, which is the subscript of the current element of the list. Another way to do this is just to iterate, as we have seen. I think I'm recording this shit, no? Am I recording or not? Funny. My god. Some int is of type list of int with count of elements. This is just a reminder. We have seen all of this. To append. Append means adding an element at the end of the list. So how you do this? You just use the method append, and between brackets you put the element to add at the end of the list. We have seen this. This is accessing the second element of the list. This is reinitializing to empty our list. Yeah, and here we have some properties. We already seen them, is empty, count, and capacity. I don't know why I'm repeating this, but just in case. Alors, paire de contenu, mais le type reste int. Okay, here we have another example. Shopping list x milk is empty, count. We talk about this. Here is another way to add elements to the list. You can just use concatenation and put the single element you wanna add in another list with the single element. Here we concatenated 2 elements at the end. We added 2 elements at the end of the shopping list by using concatenation, the abbreviated version of concatenation, which is plus equal. And again, this is the standard way. So our result will be x milk baking powder. Baking powder, I wrote it wrong on purpose. Powder should be with O and not with A, because in the next line we want to replace or modify an existing element of the list. So I wanna change this entry, baking powder. So one way to do it is just to remember its index, which is 0, 1, 2, or we can look it up using first index of it returns the index of the first occurrence of baking powder. In this case, 0, 1, 2 is the first occurrence and the only occurrence. So here you will get exactly we can check it here by doing this. Run. Okay, yeah, you can see it too. Okay, and here I'll just erase this and this, erase this. Yeah, here I added the exclamation mark because this the call of this method will not always succeed. I mean, it will the outcome is optional. is an optional integer, as you may not find the element you are looking for. But here, just to save time, I put exclamation mark to say that I'm sure that I can unwrap this result safely, which means it's not null. There is some value. Okay, here I'm just printing shopping list. Let's see what's the result. Eggs baking powder, yeah. We have corrected we have just replaced the element of the list here. So then let me just count number of elements, talk about this. Modify and segment the list, you can do it quickly with subscript. Yeah, that's Swift is very powerful and flexible. So if you wanna modify some portion of the list, you can use subscripting as I'm doing here. So from element 4 to 5, replace with banana and apples. Let me check again. The value of the list. The value of the list is eggs, milk, baking powder, chocolate spread, and then you have so 0, 1, 2, 3, 4. So 4, 5 cheese butter will be replaced by banana apples. Let us check the result. Banana apples, okay. Let's check all the values: eggs, milk, baking powder, chocolate spread, banana. Oh, it didn't change. Yeah, so why it didn't change? Because the problem is yeah, it should change. That's weird. Let me check here. I can't scroll down further. Chocolate spread, banana. Oh, there is banana, but apples are missing. Why apples are missing? There is banana and apples are missing. That's very weird. Oh, here, apples. I just needed to scroll down, sorry. My bad. Yeah, this is to change some element at specific index. We have seen this. If you wanna, till now we have seen how to insert you can insert a specific element either using directly the index as I'm doing here, or you can use this function insert, the built-in function of arrays insert. You put the value and add. Using add, you put the index. Cloning an array. To clone an array, you just declare another array, and you put the old array. Then, as you notice, if you remove, there is something wrong here. No, it's fine. And here again, I remove some element from the clone. So if you print the clone in addition, okay, but maple syrup is, because we did clone for remove, maple syrup is no longer in clone. But if we check chopping list, since it's clone, it should be different than the clone. So maple syrup is present here. I hope this makes sense. I know I'm going kind of quick, but it's not a big deal. You can just try it by yourself and notice. Apple's shopping list remove last. This is to remove the last element of the list. Is the opposite of append. This is to iterate over the list. We have seen this before. And this is another way to iterate, but this time you iterate by getting either the value and the index of the list. So in this case, for instance, when you print, you will get item 1 x y 6x should be x. Okay, this is the reason. Maple syrup, eggs, milky juice, baking powder, chocolates, spread, and banana. No, actually this isn't the reason. The reason one is not 6x, it's just x. Now to sort the list, you will need the sorted method. Don't mind this code, it's about generating random numbers. We're gonna just use it. So linear congruential generator will generate random numbers, and we will append these random numbers to some list, which is called ambir. Did we initialize ambir? Yeah, ambir. I prefer to put it here. Var ambir, it's a list of integer initialized empty, and at each time. So this is just a random number generator. Generates random. Each time you call generator.random int, it generates some arbitrary integers. Then I show the here I show the list. This is the outcome, but in this execution we may get something different. So 9, 18, 15. Yeah, this kind of random number generators is deterministic. It doesn't matter. Method sorted. Actually, this method gonna return some sorted version of the array, but it won't really sort it. So let me check. So our list is composed of these elements 9, 18, 15. Extra, it's generated by this random number generator in this loop, right? So we got this is the original list, and this is which is called mbr, and this is mbr.sorted in increasing number of values 0, 3, 7, 9. But here if you check the value of mbr, what is it? You should get something here. Okay, yeah, so here it is. As you notice, mbr didn't get ordered. To keep the ordered list, we need to save it somewhere, like I'm doing here. Let some sorted numbers receive mbr.sorted, or rather we can use mbr.sort, which is a verb compared to here a past participle. Let's check it together. Sorry. Yeah, so this is mbr after sorting, and if I check here, yeah, now it's, as you see, it's sorted. mbr got sorted. Now yeah, say you want to sort the list but in increasing number of values. In this case you will need to specify some ordering protocol. Here the protocol is between braces. Yeah, between braces. And here we're saying that the current element should be superior to the following element. So this is definition of protocol. So this is equivalent to saying sort this list in increasing number of integers. Let's check it. We should get the list reordered. What is it? Yeah, so here it's sorted. So we don't have its value. We should have its values somewhere here. Yeah. I don't know why it's not showing up. Let me try again. Anyway, you need to believe me. Again here the list stayed the same because, as I told you, sorted doesn't change the list. It just give you an ordered version of your array. mbr also mbr.sorted. Yeah. So here we get entry décroissant. Voilà. 19, 18, 15, 14, etc. Yeah, let's keep moving. Yeah, there is abbreviated way to use to sort list, and it's just by rather than specifying protocol. You can do it just by putting superior here directly or inferior. Here we have another example with an array of strings contains some beverages names. All are kind of coffee with milk. So here if you do sort, let's see what we're gonna have. Yeah, it works, and we got, sorry, let me show the result here, maybe it's better. Gonna show it here, yeah. So as you notice, it's an alphabetical ordering. Americano, cappuccino, espresso, etc. Now suppose you want to sort an array of objects. In this case, you need to define some protocol. For instance, let's say we need to order movies by their release date. Here the ordering protocol need to be comparable, some kind of comparable type, as int. A movie is defined by title and release date. Here we define the list of movies. I pick it up from somewhere from internet. I'm not really a fan of this kind of movies, by the way. Yeah, so this is a series of movies. Here is title and this is the release date. Here we are defining structure, and we are filling this structure with a couple of instances. The release date, yeah, and then to sort these movies, we gonna again use the sorted method, but we need to specify the protocol. Otherwise, Swift cannot like order this list of movies just because it's an object, it's a list of objects. So we need to do something like this, sorted by, and we define protocol between braces. We put here two elements. We define two sequential elements in the array m1 m2, which stands for movie 1 movie 2, m1 m2 in m1 dot this is the condition. It sounds kind of bizarre. It should be the opposite. It should be m1 dot release date less than m2 dot release date in m1 m2. It doesn't matter. Just remember that it's written this way: m1 colon m2 in m1 release date less than m2 dot release date. I'm gonna check if the movies are ordered. So it's the result, and as you can see, it's increasing order of release date. So 2011, then 2010. Sorry. Actually, here is the opposite. It's in a decreasing number of release date. I used superior in the protocol, and this writing is an abbreviated version of this writing. Okay, I'm gonna get something like this. The first one is 2011 to 2010, and as you noticed, the release date is decreasing because here in protocol we are ordering Swift to order in decreasing. So if you happen, there is the last thing about sorting arrays. If you happen to need mini sorting, it's preferable to include the comparable protocol inside film. So if you put film 2-point comparable, you are saying that your data structure film. So here I name it film. It's still the same as movie, but I cannot redefine movie. So I defined another equivalent structure named film. The period or column comparable. It means that film will implement the comparable protocol, and its elements or its instances can be compared one against the other. So to do that, you need to implement this static function. It's the inferior actually, or the superior. And if you define just the inferior, Swift will can deduce or can implement for you the equal and the superior operator or comparison for a comparable. So it's what we are saying here is we're saying that this is the elements of this function. You have let's say some element in the list LHS, which means an element which is at the left, and the element at the right, which means the element that just follow the current element in the list, and the return is Boolean. And the condition is the current element should be inferior to the following elements to have an ordered list in increasing number of release dates. Then we keep the other properties of our structure. Here I defined a list of some movies. My name is Nobody. The title, the release date 1973. As you may notice, these are all the names of old Western movies. specifically spaghetti movies, because I'm a fan of Western movies. So if I call sorted, let's call sorted, yeah, we got so sorted. Remember that sorted will use this protocol to sort the elements. So we will have the movie with the oldest release date till the movie with the newest release date, and this is true. 1965, 66, then 73. Now suppose we do sorted by inferior. This should be equivalent to this one, right? Because just sorted, the sorted function implemented is by default is the inferior, is the increasing number, is in an increasing number of values. Now what happens if I use sorted by superior? Notice that we didn't implement it, but as I said, we didn't implement the function superior, but as I said, Swift will do the detection for you. So I'm gonna say thank you to Swift. Let me check it. Yeah, 73, 1966, and then 65 in decreasing number of the release. That's all for arrays. You can find more details on the internet, or I mean in this reference, in the reference book I give you. This is like tutorial book with explanation and a lot of examples, or you can just look up on the internet or on YouTube. As for sets, I'm not gonna cover them here.